Alright, let's get right into Lesson 61, subsets of the set of real numbers. Now, you've been doing this probably since you were in second grade. It's probably time to really understand it and get it. These are actually on the SATs, knowing what an irrational number is, a rational number, integer, whole number, natural number. So, if you haven't gotten it yet, this would be a good time to try to get it. So, we're going to start out with this other board I have. There we go. We have a set, and anytime you have a set of numbers, they're going to put it in these braces, because braces indicate sets. So I have a set A, which is 0, 2, 4, 6, 8, 9, and a set B, 0, 6, 9. Those are finite sets because they don't have dots on them, so they're finite. And here's some set terminology. We have 6 is an element of A. Because 6 is in A, it means is a member of. So 6 is a member of A. So we use this E thing to mean a member of, or since it's an A, I always think of an element of. We can also have whole sets or called subsets of other sets. So we know that B, 0, 6, 9 is a subset of A because 0, 6, and 9 are in that set. So we can say B is a subset of A. That means that all members of, this should be B, all members of B belong to A. However, A is not a subset of B because all these numbers aren't in this set. So it's just kind of common sense there. Let's move on here to, over here, we have another set is C. So C is 0, 2, 4, 6, 8, 9. You'll notice C is the same as A. So we know that C is a subset of A, and A is a subset of C. So if they're the same, they're each subsets of each other. Now here's the part that you need to get down. We have different types of numbers. We have counting numbers. Counting numbers are things you count, so you don't start counting at 0. So you start counting at 1. So counting numbers would be 1, 2, 3, 4, 5. We're not going to have any fractions or decimals. Counting numbers are just numbers you count solid objects with. Whole numbers, on the other hand, start with 0. And the 0 is in whole. Do that. I always remember that. There's a 0 in whole. So whole numbers start with 0. 1, 2, 3, up to infinity. Integers are negative and positive numbers, but there's no decimals or fractions yet. They're just, and it also includes a 0 there. And rational numbers are all above. These are all rational numbers. What rational numbers are any numbers that can be written as a fraction. So we could write 2 as a fraction, be 2 over 1. So, and also decimals that can be written as fractions are rational numbers, like 1/2. Because 1/2 can be written as 0.5. 0.5, I mean, can also be written as a fraction as 1/2. There are decimals that cannot be written as a fraction, repeating ones. Irrational numbers, on the other hand, are numbers that cannot be expressed as fractions. And if you look over here, things like the square root of 2, pi, anything with pi, are irrationals because you cannot write them as a fraction. Even though we try to write pi as a fraction, it's not accurate. Not the whole way, it doesn't take it the whole way out. Real numbers, that's the title of this whole thing. Real numbers are all of the above. There are actually imaginary numbers, which we'll get to in Algebra 2. Those aren't real numbers, but anything that you can think of right now are real numbers. We'll notice that the counting numbers are a subset of the whole numbers. Whole numbers are a subset of the integers. Integers are a subset of the real numbers. Real numbers are a subset of the rational numbers and are real numbers. So you'll notice the whole numbers are in, the counting numbers are in the whole numbers and the counting numbers are in the integers. These are all in the rational numbers. The irrational numbers are out here. They're not underneath, they're not in the rational number category. This chart's really handy. It's all the real numbers. The irrational numbers are kind of on their own, but all the other ones can be nested inside of them. Another name for counting numbers, they might call them natural numbers. So we have naturals are inside of whole numbers or inside of integers, which are inside of rational numbers. Rational numbers and irrational numbers are inside of the real numbers. So if you need to rewatch that so that you get these down. This is what your homework's going to look like. They're giving us sets B and C, which are the same ones that we had before, and they're going to say, ask us true, false questions. Like they'll say, is C a subset of the irrational numbers? So we look at C. Are they irrational? Irrational numbers are numbers that cannot be expressed as a fraction. Well, we already said we could write 2 as a fraction, 2 over 1, or we could write it as 4 over 2. This one you would say false. They're not part of the irrational numbers. The next one is B a subset of whole numbers? Here's whole numbers. Is B part of the whole numbers? Well, let's see. Whole numbers start with 0, so that would be in it, and then it's all positive numbers from there on up. So this would be in the whole numbers, this would be in the whole numbers, and this would be in the whole numbers. So it's true. It's a subset of the whole numbers. And the final one is B a subset of the counting numbers? What's their subset? Well, let's see. Is 0 in the counting numbers? Whoops, 0 is not in counting numbers. So that one's not, so it disqualifies the whole thing. So this one will be false. So hopefully that all makes sense to you, and if it doesn't, we'll go over it in class on Thursday. We'll see you then.